Hi everyone, Mrs. V here. Today we are going to be talking about some proportional relationships between variables of volume, temperature and pressure of gases. We are going to be talking about Charles' law and Gay-Lussac's law. So let's get the whiteboard on and let's meet these scientists. So Charles' law and Gay-Lussac's law, they were discovered, well, they're actually both published, in fact, by Gay-Lussac, even though Charles was the one who discovered the relationship between volume and temperature. Gay-Lussac actually published it, and he did credit it by naming it in Charles' honour. So let's meet Jacques Charles. He lived from the middle of the 1700s to the beginning of the 1800s, and he was fond of experimenting with hydrogen. In fact, he would fill balloons with hydrogen and float them. He was even working on manned flights. So we see that here we see the type of balloon that Charles would have flown in. His first attempt was a bit of a disaster though, because even though it wasn't a manned balloon flight, he actually flew his balloon, and everybody was, because it wasn't manned, it wasn't steered or anything, everyone was just chasing after it. And it actually came down in a village, the village of Gonesse in France. And the villagers were so afraid, they weren't used to seeing things flying, they were so afraid of it, they started attacking it with pitchforks. They were absolutely terrified. And in fact, when Jacques Charles came along, they even started attacking him. So that's how they were just not used to seeing things that were flying. He did some experiments with gases. He filled 5 balloons with 5 different gases, and he filled them until they were exactly the same volume. And then he increased the temperature. And what he noticed was that all the balloons increased to the same size or the same volume if they were at the same temperature, no matter what the gas itself was. So that was his experiment. He was really more into his ballooning ideas than he was into publishing stuff about gas laws, but that was the experiment that he did. And what's the gossip on him? He actually had a very young wife. His wife was 37 years younger than he was. His wife Genevieve. Oh no, that's Gay-Lussac's wife was Genevieve. So Jacques Charles' wife was 37 years younger than he was, but he still outlived her. All right, let's move on and meet Gay-Lussac. So Gay-Lussac, Joseph Louis Gay-Lussac, his surname was actually Guy, but he was from the village of Lussac, and I'm not sure if there are any historians out there that can help me on how that ended up being his surname being Gay-Lussac. That's evidently something that happened in France at that time. He was actually also into ballooning. He actually flew his balloons up and did tests on the composition of the atmosphere at different altitudes. But what he is most famous for is he discovered that water was 2 parts hydrogen and 1 part oxygen. So he is the discoverer. He did this with other scientists as well, but that's what he's most famous for. But he actually published 2 laws on gases. The law where volume is proportional, the volume of a gas is proportional to its Kelvin temperature. And in doing that, he used the experimental work of Charles, and so he named that Charles' law. He also did more experimentation where he demonstrated that the pressure of a gas, of a given volume of gas, was proportional to its Kelvin temperature. And this, he gave his own name. This is Gay-Lussac's law. Now, the goss on him is that he met his wife Genevieve in a draper's shop. She was working there as an assistant. And what he noticed was that she was studying a chemistry textbook under the counter during work hours. So naturally, it was a match made in heaven. They ended up going on and having 5 children, and one of them actually became quite a famous chemist himself. Gay-Lussac is actually such a revered scientist in France that his name is one of only 72 names that are inscribed on the Eiffel Tower. So great scientists and engineers have had their names inscribed on the Eiffel Tower. He's on the southwest side, second in. And interestingly, in all of those names inscribed on the Eiffel Tower, there's not a single woman's name there, even though it was a woman who invented the theories of elasticity on which were used in building the actual Eiffel Tower. But there we are, Gay-Lussac on the Eiffel Tower. So if you ever get a chance to go to the Eiffel Tower, be looking out for Gay-Lussac on the southwest side. All right, let's have a look at the work of these guys. So Charles' Law. So Charles' Law, published by Gay-Lussac, says that under constant pressure, an ideal gas's volume is proportional to its absolute temperature. Now, when we talk about absolute temperature and absolute scales, absolute means the scale starts at 0. But if we're using the Celsius scale, what's really interesting is that when you plot volume versus temperature, so this here is the volume axis, you plot volume versus the temperature in degrees Celsius, you do get a straight line graph. And that straight line graph, however, does not pass through the origin. It passes through a point here. And if you do this for different pressures, so remember this has to be under constant pressure. So if we look at this first line being for the first pressure, and then we repeat the experiment but at a different pressure, again we get a straight line relationship between volume and temperature. But interestingly, we get exactly the same intercept. And this intercept occurs at negative 273 degrees Celsius. And this is what we call 0 Kelvin. Okay, get it? What we can do, however, so this is the Kelvin scale of temperature, and this is on the Celsius. What we can do, though, is if we shift that axis back and set 0 Kelvin here as that intercept point, now we have a proportional relationship. Now we have a straight line that passes through the origin. So remember, proportional means that the graph is a straight line and passes through the origin. So when we do this and we have temperature in Kelvin, then what we have is volume is proportional to temperature. And remember, proportional means if volume is equal to some constant times by temperature. Doing a little bit of algebra, we have volume over temperature is equal to our constant term, which is the gradient of the line. And if V over T is always equal to K, then if we choose a particular volume and temperature combination, so say if we're talking about this point here on the graph, then that's going to be equal to K. And then if we're looking at a different point on the graph, so this one, we'll call that V2 and T2, that's also equal to K. And if both of those are equal to K, then V1 over T1 equals V2 over T2. And that is the mathematical statement of Charles' law. So Gay-Lusaac's law is very similar. It's just that we're looking at the relationship between the pressure of a gas and its absolute temperature, and this time keeping the volume constant. So again, if we use the temperature in Celsius, and here's our temperature in Celsius, then no matter what volume of gas we set at, we get a straight line relationship between pressure. So here's our pressure and our temperature, and always the same intercept on the x-axis there of negative 273, or this is the correct figure for absolute zero is negative 273.15 degrees Celsius. So again, if we were to shift the axis back here so that that intercept point was at the origin, we would be looking at using the Kelvin scale for temperature. And from this, we find that pressure is proportional to temperature. So that means pressure is equal to some constant times by temperature. Doing our little bit of algebra, we now find that P over T is equal to our constant. And that means P1 over T1 equals P2 over T2. And that is the mathematical statement of Gay-Lusaac's law. That's all for today. I'm going to see you guys in the next video, and keep working hard till then.